Hello everyone, my name is Adhisakti Sahasrara Nugroho, and today I'll be presenting my individual work about the Lagrange multipliers. So problem 1. First we have to take a look at our question, which is we have to max out the function y equals x1 plus 2 and x2 plus 1 with the constraint x1 plus x2 equals to 21. So first, to do this question, we need to first identify what are our functions and what is the constraint. So I put here function f, x1, x2 is x1 plus 2, x2 plus 1. And then I just straight away, I times them together to make this long function, x1, x2 plus x1 plus 2, x2 plus 2. And then the constraint, which is g here, I put as x1 plus x2 equals to 21. And then now from these two functions, we can find our Lagrange function with the formula here, which is basically combining the f function with the constraint, but with lambda as a constant here. So then we can find the full Lagrange function down here, which is x1, x2 plus x1 plus 2x2 plus 2 in brackets minus lambda times x1 plus x2 minus 21. Note here the b, which is the 21, is the constraint constant. And basically what we just did is put that in with the x1 plus x2 to complete this, this function. Now that we have the L function, we can find the first partial derivatives in order to find the max values of x1 and x2, as well as lambda, but we're not looking for the lambda. So we can see down here, the first derivative of x1 is x2 plus 1 minus lambda, and then for x2 it's x1 plus 2 minus lambda, and then the first derivative of lambda is x1 plus x2 minus 21. And now, sorry for the blurry image, but to find the actual max values, we set all of these equal to 0, and then we can find these equations, which is x2 plus 1 minus lambda equals 0, x1 plus 2 minus lambda equals 0, which I note as a function. Equation 1 and equation 2, and then over here for the lambda equation, I put it as x1 equals to 21 minus x2, which we will substitute into the function later on. Okay, so now we can use the elimination method with x1 equals to 21 minus 2 into these equations, and we will be able to find the lambda value of 12. Okay, now that we have the lambda value of 12 from this previous elimination method, we can sub that into equation 1 and equation 2, and we will find the max values of x2, which is 11, and the max value of x1, which is 10. Quite simple. Okay, now problem 2, which is how do we prove that our values x1, x2 is these are truly the max. So to find that, we can use the Hessian matrix, which basically is finding the second partial derivatives of all of the possible second partial derivatives from the function that we got from our Lagrange function. So we put that all inside this matrix that you can see here. And as you can see, the x1, x2, and lambda second partial derivatives are all 0. This means that these are truly maxed out. These are the max values, while the rest are 1s, which means they are not the max values. So from here, we can see down here, 0, 0, 0 with the triangle of 1s. This means that x1, x2, and also lambda is the true max values. So that's all for my presentation. Thank you.